You've probably walked past a wall like this 100 times and not given it a second thought, right? Just a bank of smart meters. But what if this totally ordinary looking wall is hiding something? Something you can't see or hear, but that's happening all the time. To our eyes and ears, it's completely silent. It's just there. But in the invisible world of radio frequencies, what if this quiet wall is actually shouting? Let's take a closer look and find out what these little devices are really up to. All right, so to figure that out, we've got to talk about these hidden pulses that the meters are giving off, because it turns out there's a lot more going on here than just counting up your electricity usage. See, a smart meter isn't like those old analog ones with the spinning wheel. It's not passive at all. It's an active, two-way radio. So yeah, it records your usage, but it's also constantly, wirelessly sending that information out and talking with the other meters in its network. Here's a great way to think about it. One smart meter is kind of like one person talking quietly, pretty easy to ignore. But on this wall, we have 22 of them, all packed together. That's like 22 people all talking at once in a tiny space. It's not just more noise, it's a completely different level of intensity. And this communication, it's not some smooth, constant hum. It happens in these really short, sharp bursts of wireless info. We call them pulses. You can't see them, you can't hear them, but they are very real. And as you're about to see, they are very, very measurable. So what's the real impact of these pulses? Well, to understand that, we just need to look at two numbers, two specific readings from a radio frequency meter that was held right up to this wall. And trust me, these two numbers, they tell the whole story. Okay, the first number is the average reading. It's about 362 microwatts per square meter. So what does that mean? It means that most of the time, things are relatively quiet. This is the baseline, the background chatter. But then you get the second number, the peak reading. And that came in at over 1 million microwatts per square meter. Whoa, that is not background noise. That's the shout. That's the moment the pulse actually happens. And just look at this. Look at the average reading on the left. You can barely even see it. Now look at the peak on the right. The difference is just astronomical. This is why averages can be so misleading, because they completely hide these super intense, momentary spikes. To really bring this home, think about it like this. The average noise level in your bedroom at night is probably really low. But what if a fire alarm went off for just 1 second, dozens or even hundreds of times a night? You wouldn't get any sleep, right? It's those sudden, sharp peaks that can be disruptive, not the quiet average. So how intense is that peak, really? For some context, we can look at what are called the Building Biology Precautionary Guidelines. These are used all over the world to evaluate homes and sleeping areas, and they sort of classify RF exposure into different levels of concern. All right, so the threshold for what these guidelines call severe concern is anything over 1,000 microwatts per square meter. The peak from these smart meters was over 1 million. That's more than 1,000 times higher than the level considered a severe concern for a sleeping area. So that's what's going on at this one wall. Pretty wild, right? Now let's zoom out and take a look at the bigger picture. What does this kind of technological density mean for our communities? This perfectly illustrates something called the density effect. You see, 1 meter transmits every now and then, but a bank of 22 meters, they transmit more often, they relay messages for each other, and they create these overlapping pulses. The whole thing becomes so much more powerful than just the sum of its parts. Now, a really common question people ask is, okay, but they're outside the building, so doesn't that make them safe for the people inside? And that's a totally logical question. But the physics of radio waves, they tell a different story. Think about it for a second. Radio frequency signals don't just stop at a wall. I mean, if they did, your cell phone wouldn't work indoors, your Wi-Fi would never reach your bedroom, and your car radio would go silent the second you pulled into a garage. Being outside definitely reduces the signal, but it doesn't eliminate it, especially when the source is mounted directly on the wall of a living space. And it's really important to be clear here. This explainer isn't claiming these meters are breaking any government safety rules or that they're guaranteed to cause harm to anyone. That's not the point here. What this single example does show us, powerfully, is how clustered technology behaves way differently than single devices. It shows us why these peak measurements can be so much more revealing than simple averages, and why the placement and density of these devices, well, they deserve some careful attention. Ultimately, this isn't about fear. It's about empowerment that comes from understanding. When we can actually see how our modern technology behaves in our real-world spaces, we can start to have more informed conversations about how and where our infrastructure gets built. And that leaves us with one final question to think about. So much of the technology that shapes our modern world is completely invisible to our senses. And when that's the case, who exactly is responsible for paying attention?